All right. Hey, everyone. Welcome back. People hear me okay? All right. So if, as usual, you can take a second to enter your SUID so we know who's here. So today's lecture will be a choose your own adventure lecture. So I think, by now you've learned a lot about the technical aspects of building learning algorithms. And then in the third course, in the third set of modules, you saw some of the principles for debugging learning algorithms and how to actually use these tools in order to be efficient in how you build a machine learning application. What I want to do today is step through with you a moderately complicated machine learning application. And throughout all of today's lecture, I'm going to step you through a scenario and then ask you to kind of choose your own adventure. Because if you're working on this project, what are you going to do, right? And to give you more of that practice in the next, hour and a bit that we have on thinking through machine learning strategy. I've seen in so many projects, there are sometimes things that a less strategically sophisticated team will take a year to do. But if you're actually very strategic and very sophisticated in deciding what you will do next, right, how to drive a project forward, I've seen many times that what a different team will take to do, maybe you could do it in a month or two, right? And if you're trying to, write a research paper or build a business or build a product, the ability to drive a machine learning project quickly gives you a huge advantage, and just you're making much more efficient use of your life as well, right? For today, I'd like to, I'm going to pose a scenario, pose a machine learning application and say, all right, you are the CEO of this project. What are you going to do next? But I'd like to have today's meeting be quite interactive as well. So can I get people to sit in groups of 2 and ideally 3 or so, maybe plus minus 1, and try to sit next to someone that you don't work with all the time. So if you're sitting next to your best friend, I'm glad your best friend is in the class with you, but go sit with someone else, because I think I've done this multiple times and the discussion is actually richer if you talk to someone that you don't know super well. So actually take a second, introduce yourself and just greet your neighbor, I guess. So the example I want to go through today is actually a continuation of the example I described briefly in the last lecture I taught of building a speech recognition system, right? So remember, I briefly motivated this trigger word, wake word or trigger word detection system last time, where, right, I actually have both an Amazon Echo and a Google Home, but it's a lot of work to configure these things, to turn on and off your light bulbs. And so if you can build a chip to sell to, say, a lamp maker to recognize phrases like, let's say we call the lamp Robert, right? Then you can recognize phrases like Robert turn on, right? Robert turn off. And you can have a little switch to give this thing different names. You can call it Robert or Laner or Alice or something. So you can also have Laner turn on, Laner turn off, and just give your lamp a name and just say, hey, Robert turn on, right? So rather than detecting different names and turn on and turn off, I'm just going to focus on, just for the technical discussion, I'm just going to focus on the phrase Robert turn on. But it's kind of the same problem you need to solve like 4 times to give it 2 names, or to turn on and turn off. So I'm going to abbreviate Robert turn on as RTO, right? So if you want to call your name Robert and tell your lamp to turn on. I think it was inspired by, Isaac Asimov wrote these robotic novel series, and all his robots' names started with R. So maybe R as robot turn on. Let's see. So let's say that you are the new CEO of a small startup with 3 persons, and your goal is to build a circuit. Actually, your goal is to build a learning algorithm that can recognize this phrase "Robert turn on," so that when someone buys this lamp and they say "Robert turn on," that the lamp can turn on, right? And just focusing on the task of building and then to be CEO of the startup, you need to do a lot of things, right? You need to figure out how to do the embedded circuitry, figure out who the LAN makers, the sales channel. So there's all that stuff. But for today, let's just focus on the machine learning aspect of it. And so my first question to you is very open-ended. And this is the life of a CEO, right? You wake up one day and you just got to decide what to do. But so my first question to you is an open-ended question: is you're the CEO. You're going to show up at work tomorrow in your startup office, and you want to build a learning algorithm to detect the phrase "Robert turn on" for this application, right? So, so my question is, what are you going to do, right? So take a minute to answer that by yourself first. No, don't discuss your neighbor yet, but you're going to show up in your office, and then you're going to start working on this engineering problem to build a neural network to do this. So. And do this as yourself, right? Don't pretend that you're this hypothetical whatever startup CEO with $10 billion to spend or whatever. Just do it as yourself. Let's say but I don't think this is a terrible startup idea. This is not the best idea, but I think this could work. So you're actually welcome to do this. But let's say you decide to do this and you go into your office tomorrow. Like, what do you do, right? Once you take let's say 2 minutes to enter an answer, then we can discuss. In fact, I think yes. One thing I really like about answer is actually the read existing literature part, right? In fact, when you're starting a new project, and I think when you're starting a new project like that, assuming you've not worked on trigger word detection before, reading research papers or reading code on GitHub or reading blog posts on this problem is actually a very good way to quickly level up your knowledge. And I think that, it turns out that in terms of your exploration strategy, right, I want to describe to you how I read research papers, which is, so this is not a good way to review the literature, which is if the x-axis is time and the vertical axis is research papers. What some people will do is find the first research paper and read that until it's done, and then go and find the second research paper and read that until it's done, and then go and find the third research paper, and just have this very sequential way of reading research papers. And I find that the more strategic way to go through these resources, everything ranging from blog posts, lots of good Medium articles that explain things, right? Research papers, right? GitHub, is if you use a parallel exploration process where this is actually what it feels like when I'm doing research when I'm trying to learn about a new field that I'm not that expert in, right? So I've actually done a lot of work on trigger word detection, but if I hadn't worked on this before, then I would probably find, 3 papers. So again, x-axis is time and vertical axis is different papers, and read a few papers kind of in parallel at a surface level and skim them. And based on that, you might decide to read that one in greater detail, and then to add other papers that you start skimming, and maybe find another one that you want to read in great detail, and then to gradually add new papers to your reading list, and read some to completion and some not to completion. I was actually chatting with one of my friends, Peter Abiel, a former student at Berkeley, who mentioned that he was wanting to learn about a new topic, and he told me he was compiling a reading list of 200 research papers that he wanted to read. That sounds like a lot. You rarely read 200 papers, but I think if you read 10 papers, you have a basic understanding. If you read 50, you have a pretty decent understanding. If you read like 100, I think you have a very good understanding of a few, but often this is time well spent, I guess. And some other tips, again, this is like, I'm really thinking, if you really are CEO of this startup and this is what you want to do, what advice would I give you? When you're reading papers, other things to realize, one is that some papers don't make sense, right? And that's fine. Even I read some papers, I just go, nope, I don't think that makes sense. And it's not that uncommon for us to find papers from a decade ago and we learned that half of it was great and the other half of it was really talking about things that were not that important, right? So it's okay. Authors, usually papers are technically accurate, but often what they thought was important, like maybe an author thought that using Bastion was really important for this problem, but it just turns out not to be the case. That happens a lot. That happens sometimes. And I think the other tactic that I see Stanford students sometimes not use enough is talking to experts, including contacting the authors. So when I read a paper, I don't bother the authors unless I've actually tried to figure it out myself, right? But if you actually spend some time trying to understand the paper, and if it really doesn't make sense to you, it's okay to email the authors and see if they respond. And people are busy. Maybe there's a 50% chance they respond, and that's okay because it takes you 5 minutes to write an email, and there's a 50% chance to get back to you. That could be time pretty well spent. But don't bother people unless you try to do your own work. I actually get a lot of emails from high school students that do not feel like they've done their own work, and I just right. So just don't bother people unless you've actually tried to do your own work. Cool. So after looking at the literature and having a base, maybe downloading a open source implementation or getting a sense of an algorithm you want to try. Oh, and it turns out the trigger word detection literature is actually one literature where there isn't consensus on this is a good algorithm, this is a bad algorithm, right? Despite all the trigger word or wake word detection systems that some of you may use already, there isn't actually consensus in the research community today on this is the best algorithm to try. But so let's say that you read some papers, downloaded some open source implementations, and now you want to start training your first system, right? Last time we talked about this, we talked a little bit about how much time you would spend to collect data, and we said we spend a small amount of time, spend like a day or maybe 2 days at most to collect your first data set to start training up a model. But my next question to you is what data would you collect, right? In particular, what train depth test data would you collect? So you've decided on an initial neural network architecture and you want to train something to recognize this phrase Robert turned on. I think there's probably, I don't think it's possible to download the data set. I don't think anyone has collected the data set with the words Robert turned on and posted down the internet. So you have to collect your own data for this particular trigger phrase that you want to use. But as CEO of this startup trying to build a neural net to detect the phrase Robert turned on, what data do you collect, right? So once you again take, I don't know, let's say 3 minutes to write an answer to this. Yeah, I think this is an interesting one. Robert turned on over and over, and then data augmentation. Data augmentation is one of those techniques that is a way to reduce variance in your learning algorithm because you're generating more data. And having worked on this problem, I happen to know data augmentation works. Is very useful for this problem. But if you didn't already know that fact, this is one of the things I would probably not do right away, because I would train a quick and dirty system, validate that you really have a high variance problem before investing the effort in data augmentation. So data augmentation is one of those techniques that solve, it never hurts, right? Or it rarely hurts. It usually helps, but I don't bother to make that investment unless you have collected the evidence that you actually have a high variance problem and that this is actually a good use of your time, right? Yeah. And I think this one actually, this is actually nice. So record everyone started saying Robert turned on 100 times. The really nice thing about that, you can get it done really quickly. When I'm working with teams, I actually think in terms of hours, in terms of how long it takes us to do something. So this one you could probably do in 30 minutes, right? So you can get your data set collected in 30 minutes and get going. Or if you run around Stanford and just ask, friends or strangers to speak into your laptop microphone, you can spend a few hours to get a much bigger data set than possible with a startup. So I probably do that. I probably actually go and collect data in several hours rather than only spend 30 minutes. But this is actually pretty interesting as well because it lets you get it done really quickly. Does that make sense? Right? So, yeah. So let me actually share some more concrete advice, right? And I think actually sometime back, to prepare a homework problem that you see later in this course, Ken and Eunice and I were actually, building the system partially to create a homework, right? That you see later in this course. This is like this trigger word thing is a nice running example that we're using in a few points throughout this course. So here's one thing you can do, and this is actually what we did, right? Which is collect, simplifying a little bit, collect 100 examples of 10-second audio clips, right? And so it turns out once you grab a hold of someone and ask them to speak into your microphone, you can keep them for 3 seconds, which is how long it takes to say Robert turn on, or you can keep them for 10 seconds, which they're actually very willing to spend an extra 7 seconds with you, right? But so if this is 10 seconds of audio data, so this is 10 seconds of audio. Right? And audio is just patterns of little changes in air pressure, right? So if you plot audio, the reason it looks like this waveform is just the way you're hearing my voice is, my voice or the speakers are creating very rapid changes in air pressure, and your ear measures those very rapid changes in air pressure, interprets it as sound. And so a microphone is a sensitive device for recording these very, very high frequency changes in air pressure. And this plot that you see in audio is just what is the air pressure at different moments in time. Right? But so given a 10-second clip like this, if this is the 3-second section where they said Robert turn on, then what you would like to do is to build a desk lamp, say, that can sit here and the lamp is turned off, turned off, turned off, turned off, turned off, turned off. And at the moment they finish saying Robert turn on, you turn it on. So this is the output label Y really, right? And then it's not detecting the phrase, right? So what you want to do for the trigger word system is at pretty much the moment they finish saying Robert turn on, you want your learning algorithm to output a 1. That's your target label Y saying, yep, I just heard this trigger word. And for all other times, you want it to output 0. Right? And then the 1 is when you decide to turn on the lamp at that moment in time, right? So to collect a data set, here's something you can do, which is collect 100 audio clips of 10 seconds each. And, when I'm prioritizing my work or my team's work, I would really, look at these numbers and think, okay, let's say actually, if you are doing it, let's say you are running around Stanford and you want to collect 100 audio clips, maybe 10 people, 10 clips per person, or maybe 100 different people. I would actually estimate, if you go to a Stanford cafeteria, how long does it take to get one person, right? And you could probably get one person every minute or two if you go to a busy place on like a Stanford cafeteria. So you could probably get this done in like 100 to 200 minutes, like 2 or 3 hours, right? It's not that bad. So you can get this done quite quickly. And so, and let's say you collect 100 audio clips, and actually for the purposes of today, let's say you collect 100 audio clips to use for training, 25 for your dev set, and 0 for the test set, right? It's actually not that uncommon if you're building a new product to just not have a test set, because your goal is to build something that you're convinced is, just early prototyping phases of a project. Sometimes I don't bother with a test set. If your goal is to publish a paper, then of course you need a rigorously collected test set. But if you're just building a product and you don't need a rigorous evaluation, sometimes you can just get started without dealing with a test set, right? So it's pretty easy to get started. And then So taking that audio clip from above, one thing you can do to turn this into a supervised learning problem is to take, the phrase Robert turn on can be said in less than 3 seconds. So let's say you take 3 seconds as the duration of audio, right? So what you can do is clip out, so let's say here was when Robert turn on was said. So what you can do is, the target label is 000010000. What you can do is then clip out different audio clips of 3 seconds. So here's one audio clip. And you can take that audio clip, this is X, and the target label is 0, because Robert turn on was not said. And you can take this audio clip, a different randomly clipped 3-second clip, and that clip also has the target label of 0. And for this one, right, which is a 3-second clip that ends at the on, the last part of the on sound, you would have a target label of 1, right? So when you learn about sequence models or RNNs, you learn a better method than this explicit clipping. But for now, let's say you take these audio clips and turn it into so take a 10-second clip, and by clipping out different windows, you can take your, let's say, 100 clips. And because for each 10-second clip, you can take different windows, you could turn this into, let's say, 3,000 training examples, right? So here, I took a 10-second clip and took three different 3-second windows, but if you take 30 3-second windows, then each 10-second audio clip becomes 30 examples. And now you've turned the problem into a binary classification problem, where you need to train a neural network that inputs a 3-second clip and labels it as either 0 or 1. Right? Does that make sense? And so this is an example of the more complex pipelines you might have if you're building a learning algorithm to take a continuous audio detection problem and turn it into a binary classification problem, which you've learned how to build various neural networks for. Right? And again, when you learn about RNNs, you learn about other ways to process sequence data or temporal data. Okay? So, go ahead.
In the method you suggested right now, is that manually labeling the data?
Oh, is this manually labeling the data? Yes, I would, yeah. Actually, if you have 100 examples, it's not that hard to just listen to it, on your laptop with some audio playing software to figure out when they finish saying Robert turn on, and then at that moment to put a 1 in the target label, right? Because this is really when you want the lamp to turn on, right? Make sense? Cool. So, any other questions? Actually, feel free to ask clarifying questions. Yeah, go ahead.
I wonder if this is going to cause the problem that ones are too sparse.
Oh, sure. Let me get back to that. Cool.
Sure.
Anything else? All right.
Is there a specific reason we only train them with 3 seconds of voice snippets instead of 4 or 5? Like some people's voice might drag.
Oh, I see. Yeah. Oh, why do we do 3 seconds instead of 4 or 5 seconds? There's another hyperparameter you can test. Okay, so I think I don't know. You have to say it really slowly to take. I don't know, right? 3 seconds is this, right? So you say Robert turn on, right? So again, it's a design choice, yeah. Yeah. All right. So let's say you do this, feed it to supervised learning algorithm, train a neural network, and let's say that when you classify this, when you run this algorithm, you end up with 99.5% accuracy, right? But you find that the algorithm has 0 detections. Right? And what I mean is that whatever audio you give it, it just outputs 0 all the time. So the algorithm just says, nope, I never heard the phrase Robert turn on, So 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 my question to you is, and by the way, the reason I'm going through these scenarios is I found that a good way to gain good intuitions and to become good at making these decisions is these are the decisions that a project leader, right, a tech leader or CEO needs to make. These are actually like pretty much exactly the decisions you need to make. And I find that one of the ways to gain this type of experience is you find a job with a good AI team and work with them for 5 years, right? And then you actually live through this and you see what they do. But instead of needing you to go and spend 5 years to see 10 examples of this, I'm trying to step you through maybe one example in 1 hour. So instead of gaining this experience through work experience, which is great, but takes many, many years, many months, hoping to, let's just put you in the position of making these decisions. You can learn from that much faster, right? And all the examples I'm giving are actually completely realistic, right? They're either exactly or very similar to things I have seen in actual, very real projects. So question is, your learning algorithm gives this result, 95% accuracy, 0 detections. What do you do? Let me mention some of the answers I really liked. I think that, when I think of building learning algorithms, the process is often specify a dev set and or test set that measure what you care about. And then you don't always have to do it, but it's good hygiene. It sharpens clarity of your thinking, right? If you have a very clear specification of problem. And I think one insight out of this is that if your dev set is really out of whack, right? Because it's so unbalanced that accuracy in your dev set doesn't translate to what you actually care about. Because, presumably this is 99.5% accurate on the dev set as well, but this performance is terrible. So it's doing great on the dev set, on your accuracy metric, but giving terrible performance. So I think of it as good hygiene. It's kind of good sound practice to just specify, make sure you at least have a dev set and evaluation metric that corresponds more closely to what you care about. So making the dev set more balanced, equal numbers of positive and negative would be a good step toward that. And then I think you could also, there are a few people that talked about give higher weights to the positive examples, right? So, one way to do this is to resample your training and your dev sets to make them more proportionate in terms of maybe closer to balanced ratio of positive and negative examples. That'd be okay. The other way to not do resampling would just give the positive examples a greater weight, right? I would probably resample. Another thing you could do, in the interest of speed, even if it's not the mathematically most sound thing to do, is to change the target labels to be a bunch of ones. After that, and this is a hack. This is not formally rigorous. But if you've implemented the rest of this code already, this might be a reasonable, a little bit hacky thing to do, but this might work well enough, right? I don't know if I would want to try to, write an academic research paper with this method. Maybe you can get away with it, but this is all thing that I think if you try to publish a paper with this, academic reviewers might raise their eyebrows and say, maybe this is okay. But I think if you want something quick and dirty that just works, I think labeling the ones, changing a bunch of labels to be ones so that, say, a clip here, right, that ends just a little bit after Robert turned on is still labeled 1, that would be pretty reasonable. But this would be saying that for anywhere within maybe a 0.5 second period after Robert turned on finish, it's okay to turn on the light anytime within that period. That you kind of want to be turning on the light, turning on the lamp, say within half a second, right, after Robert turned on has been said, right? And this would be a way to just get more labels of ones in there, right? That makes sense? Yeah.
With rebalancing your data sets, like the class imbalance, how does that translate to when you deploy this, you're not going to see Robert turn on as much, right? 1 out of 1,000 might be reflective of what you expect to see.
Yeah, right. So I think that how to put it. So if you actually, yes, so well, this is sort of a depth set and evaluation metric kind of question, right? So couple of the metrics that people often use when actually working on this is when someone says Robert turn on, what is the chance that it actually wakes up or the lamp turns on? And then the second is if no one is saying anything to the lamp, how often does it randomly turn on by itself without you having said anything? So those are the two metrics people actually use. And sometimes you could also try to combine them in a single number evaluation metric or something. But I think that you could then define a data set to measure both of these things. And then hopefully find a way to combine them into a single real number, which I think one of the ways we talked about in the videos as well. Does that make sense? Yeah, but I think the question is really what is it that satisfies a user need, right? Yeah, and just one thing about the straightforward way of rebalancing is that if you don't do this, then your whole data set just has very few positive examples, right? And so if you throw away all the negative examples so that you cut down the number of negative examples until you have exactly equal numbers of positive and negatives, you've actually thrown away a lot of negative examples. Does this make sense? And so one problem with the straightforward way of rebalancing is that, in your audio clip, in your 10-second clip that we collected by running around Stanford, you have one example of Robert turn on. And so if you want exactly perfectly balanced positive and negative, it means that you're allowed to only clip out one negative example out of this. So you can say that's a negative and that's a positive, and you can't clip out more negative examples from this, right? So if you insist on the perfect rebalance, you're actually throwing away a lot of negative examples that could be helpful for the learning algorithm, right? All right. So, a lot of the workflow of building learning algorithms is building learning algorithms feels more like debugging, right? Because what happens in a typical machine learning workflow is you implement something and it doesn't work, so you figure out what is the problem, so you fix that. Like rebalancing or reweighting or adding more ones. And so that fixes the current problem. And then after fixing the current problem, which is the one we just solved, say, you then come across a new problem and you have to solve that. And you fix that problem, you come across another new problem. So I find that the workflow of when I'm working on a machine learning project, it often feels more like software debugging than software development. Right? Because you're often trying to figure out what doesn't work and then trying to fix that. And after you fix that problem, then another bug surfaces and you squash that and you do that and another, and you kind of keep doing that until the algorithm works. So if I keep talking about, your algorithm doesn't work, what do you do next, right? That's kind of the theme of today's presentation. But that is what the workflow, that is what your day-to-day work of developing a learning algorithm is usually like, because it's like, it doesn't work, you fix it, it still doesn't work, so you fix that, it still doesn't work, you fix it, and you do that enough times until it works, right? That is actually what often working on the learning algorithm looks like. All right, so let's say you fix that problem, and you conclude through doing error analysis that your algorithm is overfitting. Right? So, you've added a lot more ones, so the data set is a little bit more balanced. So let's just add a bunch of ones like I did on that previous board, right? Let's just add a lot of ones here, so the data set isn't as unbalanced. And let's see. Right, okay, good. Let's say that, sorry. Too many pages of notes here. Okay, good. So let's say that you find that it achieves now 98% accuracy on training and 50% accuracy on the depth set, right? So very large gap between your training and your depth set performance, and so a clear sign of overfitting. And so I think on one of the earlier questions, someone talked about data augmentation. And so when you have this clear sign of overfitting, this is a good time to consider data augmentation. Right? And so let's say you go ahead and do data augmentation. So for audio, this is how you could do data augmentation, which is collect a bunch of background audio. So I guess if you're trying to build a lamp that might go into people's homes, then you could go into your friends' homes and, with their permission, record, right, what the background sound in their home looks like. Maybe with people talking in the background, maybe with TV on in the background, whatever goes on in people's homes. And then it turns out that if you take say a 1 second clip of Robert Turn On, of RTO, and you add that to a background clip, then you can synthesize an audio clip of what it sounds like in your friend's house if someone were to suddenly pop up and say Robert Turn On against the background sound of your friend's house, right? And it turns out that if you want to make the system robust, so actually, for example, I have I actually know someone that lives unfortunately closely to a train station, and so their house actually has a lot of train station noise from the Caltrain. And so what you can do to make your system more robust is also take, a clip of, say, train noise, right, like Caltrain noise, and if you take that noise and take in this case, let's say 1 second or 3 second clip of someone saying Robert Turn On, and you synthesize that on top of the train in the background, then what you end up with is a 10-second clip of someone saying Robert Turn On against a noisy, train in the background type of noise, right? And so in order to do data augmentation or data synthesis, you can take some 1 second clips of people saying Robert Turn On in the quiet background, and then take some 1 second clip of people saying random words, right? Let's say, cardinal, right? Since it's Stanford, and synthesize this against the train noise background. And then you would have, in this case, you would have what sounds like train noise, Robert Turn On, train noise, cardinal, right? And then you could generate the labels now as zeros there, ones there, and then zeros there, right? Because if this is what it actually sounded like in a user's home, then you want the lamp to turn on after Robert Turn On, but not after these random words. You can pick different random words, right? So let's see. Right. So what I'd like you to do is evaluate 3 different possible ways to collect noisy data, right? To collect this type of background data, right? And so what I'd like you to do for the next question is, let's say you and your team, have brainstormed a few different ways to collect this type of background noise data. And let's say you've decided that you would like to collect 10 hours of background noise data, right? Okay. So I'm going to present to you 3 options. One is run around Stanford and place microphones around Stanford or in your friends' homes. Do this with consent and don't California, actually, you're not supposed to, don't record people without their knowledge and consent, right? Second is download clips online, right? It turns out if you go to YouTube, there are these like 10-hour long clips of, rain noise or cars driving around, right? So you actually, and again, if you do that, find something that's Creative Commons and sort of appropriately licensed, right? Another thing you could do is use Mechanical Turk. Amazon Mechanical Turk. We can have people all around the world be paid, modest amounts of money to submit audio clips, right? So for the next exercise, what I want you to do, because, and I want you to have this exercise of this discipline, which is, what I want you to do is, I want you to estimate, let's see, what time is it now? Okay, it's 12:30 p.m. right now. What I want you to do is write down 3 numbers in the next exercise to estimate if you were to do this. Let's say you were to go do this right now, right? By what time will you have finished if you were to do option 1? What time would you finish if you were to do option 2? What time would you finish if you were to do option 3? If your goal is to collect 10 hours of data through one of these mechanisms. Does that make sense? So it's 12:30 p.m. now. So what I'd like you to do is just write down 3 numbers. First number is, what time is it? What time will it be by the time you collected 10 hours of data, from around Stanford? What time will it be, right? And if you could do this so if you think you'll do it by tonight, then write 9 p.m. If you think it'll take you 1 week, then write the date 1 week from now, right? Or whatever it is. But just write down 3 numbers for these 3 activities, okay? Why don't you do this one relatively quickly? Can people do this in like maybe a minute and a half? All right, cool. This is interesting. Yeah, what do people think? Actually, this is surprisingly large variability. I'll mention one thing that surprised me. I'll give you my own assessment. I think that when I'm leading startup teams, we tend to be very scrappy, right? And so I think that if it goes to collect 10 hours of data, if you have 3 friends with laptop, you can collect 3 hours of data per hour because you have 3 recordings going in parallel. So if I were doing this with, say, 2 other friends, I bet we could get this done by tonight, right? Because if you need 9 hours of data, that's each person needs to collect 3 hours of data, and you run around Stanford and keep the microphones running. I bet I could get this done by 6 p.m. Right? Maybe even earlier. I don't know. Download clips online. It's actually, I don't know, it's actually an interesting one. Maybe about the same time. It turns out one tricky thing about downloading clips online is that I think a lot of there are people that have trouble sleeping at night, so they listen to highway noise or whatever, right? And so there are these, 20 hours of highway clips, highway noise on YouTube that you can find. But I don't know how those clips were generated, and I suspect a lot of them loop, right? Meaning it's the same 1 hour played over and over. So I actually think it's harder than one might guess to get 10 hours of non-repetitive data. And it's one of those things, if I take an hour of highway sound and loop it, you can't tell the difference because all highway sound sounds the same. I just can't tell 1 minute of highway sound from another one. But if you have 1 hour of highway sound looped 10 times, the learning algorithm will actually perform much less well than if you have 10 hours of fresh highway sound. So this I would actually have a harder time doing. I think I would if I were doing this, because of these problems, I would probably budget until sometime tomorrow, right? Maybe 9 p.m. or something. Maybe that's doable. I'm not sure. The one surprise to me was some people thought they could do this by tonight. Again, I've used Amazon Mechanical Turk. It's actually a huge process to set up Amazon Mechanical Turk, get people on board, and especially to get them microphone. I don't know if you implement something on Flash so you can speak in their web browser, and Flash isn't really supportive. It's actually not that easy to get a lot of Turkers to do this, and the global supply of Turkers is also unlimited. So if I were doing this, I would probably, I don't know, maybe a week or something, right? Hard to say, I'm not sure. But so the specific opinion isn't that important, but I want you to go through this exercise because this is how efficient startup teams should, brainstorm a list of things, and then you all figure out how long you think it'll take to do these things. And I think we can have a debate about how high quality the data is. I think you can get very high quality data from this and from this. I just don't trust a lot of those online audio sources. But if this is really fast and you can get pretty high quality data, I would probably do this to collect the background sound to get going. right? But I think that part of the workflow I see of, fast-moving teams is pretty much exactly what you did, which is why I want to have that exercise of brainstorming the list of options and then really estimating, what time can we get this done, and then use that to pick an option, right? And then I want to just mention one last thing, which is that these differences matter, right? I've actually I built a lot of speech systems, built a lot of machine learning systems. But, and I think, by the way, if you do everything we just described, and you see this later in a problem set, you can actually, with this set of ideas, pretty much this set of ideas that we just went through today, you can actually build a pretty decent trigger word detection system, or wake word trigger word detection system. And in fact, we'll ask you to do pretty much this in a later homework exercise. But now you know when you get to that homework exercise, when you do RNNs of, how you could come up with this sort of process yourself if you didn't already know how to make these types of choices. Yeah, good question.
Just one question. At what time of my research do I have to think about which kind of how my micro will affect my results? For example, at the beginning I could think it's not important if my micro found on the light is the same as the one that is used when I run Stanford or when I download Clip, but it might mess a lot my data. So at what point do I have to think about it?
Yeah, so my advice, so what does your microphone affect your results, right?
Yeah,
so
exactly.
my advice would be to get something going quick and dirty, and then develop a dev set, right, with the actual types of data you think you get on your real microphone, and then see if it is a problem. And it may be. Different microphones do have different characteristics, and if it is a problem, then go back and think about how you collect data that's more representative of how you test. Right? I want to mention one more quick thing. They want to handle the class surveys. I want to do something real quick, which is I want to tell you why these things really matter, which is if this is performance, right? Let's say error, and this is time, right? And if this is today, and you're the CEO of this startup, remember, that's what we're doing in this lesson. And this is 6 months from now, and this is 12 months from now, right? Maybe of a competitor, actually, maybe, I don't know, maybe because we talked about this so much in this class, maybe 2 of you in this class are going to build this startup, but so maybe a competitor. But over time, most machine learning teams, the error actually goes down over time as you work on problems, right? I mean, this is what I see in tons of practical projects. You work on the project, improve the system, and the error actually goes down over time as you work on this over the next 12 months, say, right? If you're really CEO of a startup doing this. And it turns out that it's the startups that have the discipline to constantly be the most efficient. Don't do something that takes you 2 days if you can get a similar result in 1 day. The difference is not that you're 1 day slower. The difference is that you're 2x faster, right? And having that mindset, if we can take this whole chart and compress it on the horizontal axis, then you want to be the startup that makes the same amount of progress in 6 months instead of 12 months, right? And because if you're able to do this, then your startup will actually perform much better in the marketplace, assuming accuracy is important, which it seems to be for wake word. And so don't think of this as saving you a day here and there. Think of this as making your team twice as fast. And that's the difference between this level of performance and that level of performance. So that's why when I'm building teams and executing these projects, I tend to be pretty obsessive about making sure we're very efficient in exploring the options, and don't wait till tomorrow to collect data of dubious quality when you have a better idea of collecting data by today. Because the difference is not that you wasted 12 hours, the difference is you are twice as slow as a company, right? So I think, so hopefully through this example and your ongoing experiences throughout this quarter can help you continue to get better at this, right? Last thing we want to do was we're about halfway through the course. Go ahead. We want to hand out a survey, an anonymous survey, to get some feedback from you about this class. And whenever we get these surveys, we end up, thanks to previous generations of students' feedback, we've already been gradually making the class better. So I think Ken and I actually read all of these questions ourselves and try to find ways to take your feedback to improve the class. So if you can take 5 minutes to fill out the survey, and you can hand it in, just drop it off anonymously. up here in front. We're very grateful for your suggestions. Okay, so I think if you haven't entered your ID yet, you could still do so, but that's it for today. So please fill out the survey and anonymously just drop that back in front, then we'll wrap up. Okay, thank you.